Hello class, this is section 2.3, Conditional Statements. Your learning objective for this video will be to write and determine truth values of conditionals, converses, and biconditionals. So first let's talk about what a conditional statement is. A conditional statement is an if-then statement. For example, if you live in Missouri, if you live in St. Louis, then you live in Missouri. So this will have two parts. It will have a hypothesis, which is the if statement, and a conclusion, which is the then statement. So our hypothesis of our example is if you live in St. Louis. The conclusion is then you will live in Missouri. This can also be written in symbolic form, which is the P arrow to the Q. So this is read as if P, then Q. P is the hypothesis, Q is the conclusion. These are just symbolic forms for hypothesis and conclusion. For these examples, I want you to identify the hypothesis and conclusion of each. If a polygon has 6 sides, then it is a hexagon. The hypothesis is if a polygon has 6 sides, because it starts with the if, and the conclusion is then it is a hexagon, because it starts with the then. Next one, another performance will be scheduled if the first one is sold out. On this sentence, if the first one is sold out is your hypothesis, and your conclusion is another performance will be scheduled. Even though this doesn't have the then statement, it still is coming after the if statement, which makes it the conclusion. The hypothesis will always have the if statement. If the forecast is rain, then I will take an umbrella. Here, our hypothesis is if the forecast is rain. The conclusion is then I will take an umbrella. Now I'm going to give you a couple of statements and you have to write them in if-then form. So the first statement says a rectangle has 4 right angles. We are going to write this as if a figure is a rectangle, then it has 4 right angles. So you have to make a hypothesis and a conclusion out of that statement. The next one, a tiger is an animal. The conditional statement would be if something is a tiger, then it is an animal. Now what you thought in your mind could have been differently than what I wrote down. You might have written if a mammal is a tiger, then it's an animal. These sentences can vary, but they will basically all be the same. So why don't you go ahead and try these on your own. Pause the video and then I'll go through the answers. First one, 4 quarters can be exchanged for a dollar bill. Your conditional statement could be, if you have 4 quarters, then you can exchange them for a dollar bill. Like I said, yours may have varied a little bit, but as long as it's basically the same, then you're correct. The sum of the measures of 2 supplementary angles is 180. A possible answer could be, if the 2 angles are supplementary, then the sum of their measures is 180. And then the last one, a mammal is a warm-blooded animal. If an animal is a mammal, then it is warm-blooded. You could have put if something is a mammal, then it's a warm-blooded animal. Anything like that would work. Now let's talk about truth value. A conditional statement can be true or false. For it to be true, the hypothesis has to be true and the conclusion has to be true. If a conditional statement is false, then you should be able to find a counterexample for which the hypothesis is true and the conclusion is false. So let's read these three conditional statements and decide whether they're true or false. First one, if you divide an integer by another integer, the result is always an integer. So remember that integers are whole numbers. They're either positive or negative. Whenever you're trying to determine if something is true or false, always try to prove it false. If you can't prove it false, then that means it's true. So, can we think of two whole numbers that whenever you divide them, they don't equal a whole number? This is going to be false, because we can think of an example. For example, if you divided 3 by 2, you would get 3 halves or 1.5. That is not an integer. That's a fraction or a decimal. You could have done 5 divided by 3 or 100 divided by, I don't know, some 17. Anything that wouldn't equal a whole number. Next one, if the next month is August, then it is July. Well, July is the only month right before August, so this statement's going to be true. And then the last one, if angle A is an acute angle, then the measure of angle A is 35. So can we think of an acute angle that's not 35 degrees? Yes, we can, so this is false. You could pick any measure between 0 and 90 degrees. So, for example, a counterexample would be 45 degrees. Converse. A converse is going to switch the hypothesis and the conclusion. So the symbolic form is right here. You can see this is if Q, then P. Remember that Q is representing the conclusion and P is representing the hypothesis. So let's try an example. Our conditional statement says, if an angle is an obtuse angle, then it has a measure greater than 90. So what we're going to do is we are going to flip the hypothesis and the conclusion, but you are going to leave the if and the then where they belong. So whenever we flip the information, leaving the if and the then where they belong, sorry, there's then, your converse would be, if an angle has a measure greater than 90 degrees, then it is an obtuse angle. So all you're doing is switching the information from the hypothesis and the conclusion. So for each of these, we're going to write the converse. First one, if you eat your vegetables, then you grow. We switch the hypothesis and the conclusion to get, if you grow, then you eat your vegetables. Next one, if you do not work, then you do not get paid. The converse would be, if you do not get paid, then you do not work. And the final one, if a substance is water, then its chemical formula is H2O. The converse, if its chemical formula is H2O, then the substance is water. The last type of statement we're going to talk about is a biconditional. When a conditional and its converse are true, you can combine them as a true biconditional. So this says if, well, the if goes away, sorry. This says P if and only if Q. I'll explain what that means in just a second, but this is the symbolic form. So, first step is to take away the if-then. The if-then is going to disappear. Instead of if-then, you're going to fill in the middle with if and only if, or you could abbreviate it as IFF. So let's try an example. I'm given the conditional. If two angles have the same measure, then the angles are congruent. Is this true or false? This statement is true. So now let's look at the converse. If two angles are congruent, then the angles have the same measure. Is this true or false? This is also true. So since the conditional and the converse are both true, I can now write a biconditional. For the biconditional, I take away the if-then, and I replace in between the two statements with if and only if. So my biconditional will read, two angles have the same measure if and only if the angles are congruent. So here is a chart showing the three things that we went over. conditional statements, which are if-then statements, converse statements, which are flipping the hypothesis and the conclusion. So here's hypothesis, conclusion, here's conclusion, hypothesis. And then the biconditional, which allows you to go both ways. That's why the arrow is pointing both ways, because it means whether you read it this way or this way, it's going to be true. Alright, don't forget to fill out your WSQ and I'll see you in class.